15. So Archit is the only one here, but Archit remembers working out of my house for like a couple months.
Oh yeah.
So we were 15 in there, and then when we moved here, we maintained. Remember, I talked about we brought in a bunch of interns over the summer. We actually doubled the size of the company just with interns. And what's different about Atlis versus other companies is our interns, which some of them are still here, they do mission critical projects. We don't give them tasks like, hey, go like cycle this resistor and do this thing. Our interns were designing charging systems, inlet handle systems for the charging station. Some of them were doing battery pack systems, control systems, wireless communication for the charging station. Power electronics, yeah.
When you say the charging station, are you talking about high-speed chargers?
The AAC system that's in development today, so we'll have a 1.5 megawatt system versus Tesla's 250. We do know they're working on a mega charger.
Those are for heavy trucks, though, right?
Yep. So, but our system is consumer driven. So, hang on one second, I'm gonna grab something here. Just a 3D printed prototype, but rather than be focused on commercial applications, we're focused on something along these lines. This was the first prototype,
wide.
but this is it's no bigger than a CCS handle, really. Maybe a little bit
larger.
This
is big.
Yeah, but this is 1.5 megawatts. So you're talking about a difference of like 350 kilowatts to 1.5 megawatts. So almost, what, 4 times?
Yeah, and I'm only getting 90, like I said earlier, on my car right now. I can't get more than 90.
It's like comparing car parts to locomotive parts.
Right. So, but we're really trying to focus on, the rule is my grandmother has to use it. So it's not something where it's an industrial application. It has to be one of those situations where somebody that can fill up their gas today at a gas station with a normal pump should be able to use this system. But we need to bump that power way up to be able to accomplish this. So this is the first sort of 3D printed concept of that. And actually, there's science and stuff that went into this. We have a new system that's in development today that's built on this concept, using the same approach and stuff, just different connector geometry and stuff, just based on the power requirements and stuff. It's kind of like finalizing it.
Right, like an industry standard?
No. So we're not going with CCS or Tesla standard.
So you're developing your own industry standard for this type of an application?
Right. So we're actually developing the inlet, that mechanism, the cable systems, and all of that stuff is being developed in-house. Because you can't buy it.
Right.
If you were to use industry standard contacts and connectors, like if you use the ones that are similar to what they use in CCS or Tesla, you'd have 8 of those.
They don't have the highway isn't wide enough, right?
Yeah, it's not enough contact area to meet that requirement.
Yeah.
So we're talking 1600 volts, 1000 amps. So it's actually 1.6 megawatts when you think about it that way. But we only need 1.5 roughly for the pack, the largest pack that we have, plus some for heating and cooling systems. Again, it's for Atlis, we're building battery tech, but we realize you have to solve the charging side of it.
Yeah, so you're planning your own complete network of chargers.
Correct. Yeah, so the business is built in energy, platform, and vehicles. The energy group is really focused on, 1, building the technology to make this possible, but number 2, we're also looking at the infrastructure side of it. We don't want to just be a company that sort of deploys charging stations at Walmarts and stuff like that. We're looking at the complete picture of that infrastructure. So charging depots and things like that of that nature.
They're going to be drive-through, right?
Drive-through, always drive-through.
Because I've had such a pain in towing.
No pull-in park scenario. Maybe for CCS, just because, why not? But even then, we're looking at pull-through scenarios because there are vehicles coming up that use CCS that are going to be towing and hauling.
Yes.
So we might as well make that a much easier implementation for them. But I look at it this way: is imagine someone else driving up in a competitor's vehicle or another vehicle using CCS, and they're sitting there for an hour and a half. And in that time period, 6 Atlis trucks are going to go through.
With massive trailers and stuff and heavy weight.
Right. So, but to do that, we have to develop this tech. So over the summer, our interns work on critical path projects like that. They get real world experience, not tedious tasks. And that's how I came up through school. And that's the expectation that we have here is no one just comes in and does a simple thing. Everyone does a lot of stuff.
All right. Right.
We put it in the, we're looking for a CFO currently, and in the middle of that, I jokingly said in the middle of it, one of the skill sets is that they have to be able to unclog a toilet, and that is actually in the job description that Tamika posted up there, because it's true. I clean restrooms. These guys clean the restrooms. We all do.
If someone made a mess in there, they know, right? You're gonna find out who it was. You go clean your own mess.
But the reason for that is very simple: is that there is no such thing as that's not my job.
Mm-hmm.
So Archie came on board for structures, right? And you're doing structures today, but he's also doing heating, cooling systems, fluid dynamic systems. He's doing, I mean, you did wiring and brake-by-wire systems when you started as well.
Yep.
So the team members that come on board, they have to be able to tackle problems that are uncomfortable for them. And
that's how you grow, right?
That's how you grow.
Innovate.
And then we talk about intern programs and stuff like that. Where we started the conversation is that those team members come on board, they're inexperienced, they've never done this stuff before, they have to be able to do this. And if you want to, and this is just my personal opinion, if you want to be a successful engineer in your career, you have to learn every aspect of that. You cannot specialize. Don't be specialized in one little area and say, well, someone else is going to do the CAD, someone else is going to do this. You have to understand that whole system, because let's say things don't work out, or you want to change jobs or careers or move, you now have a set of skill sets that you can apply in any industry, any application. So that's what we try to teach our interns. And we've hired a few, and now 4 of them, I think now, are now full-time junior engineers or Atlis employees. So we kept some on for the fall, but we've got one, he's not even graduated yet, but he's actually working as a junior engineer. We've got another one who has not graduated yet that's in Florida. Actually, he's working as a junior engineer now, as a full-time junior engineer. A lot of that is COVID-driven, because Colorado, Kishore, right?
Yep.
Yeah.
And he'll be coming on full-time in the summer.
Yep. So we've got a lot of these guys that are sort of slated to be full-time, or some that we've just brought on board. Some of our mechanical engineers, or one of our mechanical engineering interns, he does product design. He did the mirror design, actually, the mechanisms for the mirror designs. He's doing body structures for our digital mirror system.
Digital mirror system.
Yeah, so it's all camera based.
Okay, so you're not going to have any outside mirrors.
No.
Because especially on those medium duty trucks, you see them, there's giant mirrors out. They got a big trailer. You don't need that.
Yeah,
you don't need it all.
This is coming from a guy that loves trailering mirrors. I don't understand why you buy a truck that doesn't have them.
They stick out so wide. Yeah.
Right. But they're the most useful, like, sort of system that's on those vehicles, which means that's the bar for a camera system.
All right.
Camera system has to do that plus more.
All right.
So
gotcha.
Our mechanical intern actually did the electronics, internal stuff, mechanisms and everything for the motion of those things. He's doing field of view. He's doing basically a lot of the system development for that. And he actually designed the first concept for it. But then at the same time, he's also doing structures, frame structures. He's painting the box truck, like whatever has to be done, he's doing that. And he's eager and he's hungry to be able to do that. And those are the kinds of people that we love here.
Yeah.
It's just the people that are like, what needs to be done? Okay, I'll jump on that and I'll punch that out and get that moving. So from a design aspect, I look at it this way.
This is for the life cycle of the battery pack.
Yeah,
you're putting a tremendous amount of electricity at an incredibly fast rate.
Correct. So we really want to, so everything we do is customer backwards, right? So I look at trucks today last 20 years.
Mm-hmm. Before it goes into the junkyard. Yeah.
Correct. Now we're not looking at junkyard scenarios. We're actually looking at a different business model, which we could talk separately about that.
All right.
When we think about that, I think typically that's a few 100,000 miles of operation. But sort of the world that we're going to is million-mile operation.
Yeah,
vehicles.
I agree. I think that any well-designed electric vehicle should last 1 million miles.
Correct. So when we look at cycle life and use cases, and we talked a little bit about this before, we target 1 million miles consistent experience for that entire 1 million mile life. So that's our target numbers.
All right.
We do have a minimum number that we're willing to accept, but 1 million miles is the target number. So we always push the team to aim above that. So we think 2,000 cycles, 500 miles range, we think 1 million miles. Right? It's a very basic number.
All right.
That number could come down, of course, when you start thinking about if everyone is a towing scenario
Right.
and full load, then that number is obviously going to come down. But that's also a higher, like it's a heavier scenario, or sorry, a much more brutal scenario for that vehicle to undergo.
True. It's the most difficult.
Correct. So
type
other
of
things
driving.
are also going to start wearing out if you're doing that particular thing for every second, every mile of that journey.
Right. So you got to
throughout
look
life
at
of
the
that
whole
vehicle.
thing, not just the batteries. Yeah.
Correct. So that brings us into sort of the subscription circular economy business model, where we're actually thinking about, continuous hardware upgrades for vehicles.
So
over the life of them.
you don't change the vehicle, you just upgrade.
You just upgrade. So you might get a new vehicle in 3, 5, 7 years, or when you sign up for an Atlis vehicle, and not all details of this are obviously worked out yet, but when you sign up for an Atlis vehicle, we're looking at never buying another vehicle again.
Your last vehicle.
It's your last
That's it.
vehicle. It's your first vehicle, maybe, and it's your last vehicle you'll ever own until you can't drive anymore.
Okay.
And think about not just continuous software updates, but continuous hardware upgrades and things like that over the life of that vehicle for 20, 30, 40, 50 years. And in 50 years, that vehicle might be completely different.
Okay. True.
But it's this continuously
It's like a
improving
metamorphosis of the
experience.
same vehicle.
Correct. And then when we think about parts that have defects, let's say we'll pick an easy thing, a motor. When that thing breaks down, we bring it back in, we refurb that, but we're not waiting to refurb that to put it back in. We put another one in, keep you on the road, keep you going. That one gets refurbed, it goes back into the maintenance pile, and then for the next person, that one goes back on. But there's a guarantee that that one's going to last a certain amount of time, and when that or any other component fails, it follows that cycle
Okay.
and that process. So when it comes to battery testing, we compare industry standard versus what Atlis is doing. So if that industry standard application has a certain cycle life that's designed into it, we then compare Atlis's cycle life under a fast charging and standard discharge scenario. So we don't fast discharge the cell, but we talk about a certain discharge profile that fits within the
Does fast
test parameters.
discharging affect the battery life negatively?
It can, yes. So it can, absolutely. But temperature management, all these other things also play a role in that.
Yes.
So what we do is we actually compare what the industry standard is versus Atlis to see if there's, do these curves diverge? Do they stay parallel to each other or in line with each other? Is Atlis doing better? And the data that we've collected so far to date indicates that we don't see a negative change in cycle life of the cells, which means if we say it's 2,000 cycles, what we're aiming for is 2,000 cycles fast charged every single time. And the data we have today supports the fact that we're not seeing a degradation in that cycle life
Okay. Very good.
with what Atlis is doing. In fact, they're right in line with each other.
Okay, so what were you saying about the cells? Like I got my Tesla has the old Panasonics that were
Right.
originally designed for laptops in my vehicle.
Yeah, so
What
you're
I've got.
talking about a consumer-driven product, and you're trying to get reliability out of that. And in the consumer market, long-term reliability, cycle life, and things like that are not, they're not necessarily the most important thing in the world. So they have a lifespan, right? Maybe it's a year or 2 years or something like that. So in order for them to build this market at that particular point, they had to work around that problem. Today, what Atlis is really focused on is the cell technology designed specific to the application. So not necessarily taking a consumer-based product and then plugging it in here, or even a somewhat improved product and then plugging it in here. We're developing cell technology that's very specifically designed to operate in these conditions, in this environment, not just from a use case scenario either, but from a manufacturing scenario, from a test scenario, from reliability, end of life, what do we do with it? All of that stuff is being taken into account versus taking something, a piece from a catalog, plugging it in, testing it, seeing what the characteristics are, and then basically building your vehicle on top of that. We're actually going, what is the customer requirement, building it at the cell level out to ensure that when we get to the vehicle, it meets those requirements.
All right, so even if someone doesn't understand all these things, they're just going to have an overall better experience.
Yeah, it's consistency in that experience. It's getting something that really truly feels like that leap forward versus a leap backwards.
All right, so what is your cell, your battery cells, the design, and how is that different than what most folks are doing in the market right now?
Right, so most of the market is focused on buying an off-the-shelf solution, maybe with a selected chemistry that's kind of off-the-shelf for them today. But those cells are not designed very specifically for things like thermal management. They're not designed for the application. So Atlis is designing and developing cells that are very specifically designed for the application. Thermal management is an 80% priority for us. Selecting the right chemistry is a massive priority for us. So the teams are really focused on getting those right for the specific application, but we're also looking to basically eliminate all the middlemen that are involved there as well. We're not looking to buy something from a vendor and they have to make a profit on that. They also then control the supply, they control the cost of that, they control all of that, and then we're competing with the other companies that are on the market. By Atlis bringing all of this in-house, that means we control that entire sort of supply chain path from the raw materials all the way up till the end product that's in there. So that's how we drive costs down.
Right.
But it's also how we're able to drive innovation at a much faster pace.
Yeah, and
you don't have to convince someone else to build something they've never built before when everyone else is buying something else, so therefore they don't want to build this new thing. We're actually able to do that, and we're able to do it much faster, we're able to do it much cleaner and control that cost.
All right, and you've got a specific product that is different than most automotive manufacturers. You're doing trucks. So you're going to have a different set of goals in mind with what you want.
Yeah, so we're not focused on commuter traffic and day-to-day stuff. We're focused on towing, hauling, heavy-duty use cases. We're focused on more extreme environments. We're focused on sort of what a pickup truck is intended to be used as versus the sort of 80% use case, which is the consumer market. And to be able to do that well, we have to do that from the cell level all the way out.
All right, well, with all the space you've got here, where are the trucks going to be built?
So the trucks themselves will be finished assembled here, and the majority of the components will actually be built here. So with this space that we're in right now, a majority of this will actually be taken up by the energy team with a focus on building battery cells as well as packs. So we're going to manufacture the cells, the packs, the integration of all of that stuff in here. And then of course the platform assembly, motors, gearboxes, all of those different systems, control object systems and everything else will be finished assembled here. Individual components will come from suppliers, but we're not using tier 1 suppliers. So we're not using subcontractor engineering development suppliers to build or to design, develop, and assemble subcomponents. We're actually using a few steps below that in terms of suppliers. So we're getting individual components and parts. We're developing that stuff in-house. We'll bring that in and we'll actually do finished assembly there and then final integration into the platform. The vehicle to start, the body in white will be built by someone else. They'll come in, we'll integrate Atlis components, interior systems inside that, and then just drop that on top of the platform and drive it out the back.
So there'll be finished products will be rolling out here of Mesa, Arizona then?
Right here in Mesa, Arizona. Yep.
What is it that thing showing it sounds really accurate, like within 1,000 of a...
All right, so this is one iteration of the suspension.
Yeah, so here, like all of this stuff is done through a concept of generative design. So we talk about 10,000 pounds per axle. It's roughly 5,000 pounds per corner. So this is a custom airbag shock design using an existing sort of shock geometry and setup, an existing bag, and then all of this stuff was custom developed for this prototype. And this is all 3D printed. And then these upper and lower control arms are actually designed for the load characteristics and everything, but it's all simulation computer generated, so it's not drawn. We set up all the hard points and everything else, the loads, all those dynamic conditions, and then the computer software actually generates all of these things, and then we 3D print it and assemble it for the prototype. So this thing actually does move up and down. It's functional in that aspect. And then Atlis designs we actually did the knuckle, the hub assemblies, all of that stuff is in-house developed because we can't buy anything that exists today that can handle these loads for an independent suspension system. So all of these internal components and everything, we can't just go out and catalog by it. Yep, the brake systems are Willwood. So this is their particular design for these systems and their caliper for our load rating. But then the hub and everything else that's inside, the knuckle and stuff, all that is Atlis designed. And then the shock system, that air spring shock system that you see there, that's all Atlis proprietary tech.
I used to be a CAD drafter, and I don't even know how to calculate these angles and curves.
You can't. That's all computer generated.
That's amazing.
So it's a very cool concept, because this stuff right here, if we can find a way to manufacture that on a large scale, that would be a lighter, stronger system than a typical like casted or CNC system that's on the market today. The challenge is, like, those pieces there can only be made through additive manufacturing processes. Or you could do like a investment or sandcasting process or something like that, where you like throw material away when you're done, but it's not very cost effective at high volumes. So this was an exercise we went through as we developed the geometry and everything for that system, air springs, shocks, all of that stuff, printed that off, and then this was a motion simulation system that we were demonstrating actually for a different investor day for that particular setup. But this is a concept. These are technologies that we're actually actively looking for or looking at to implement into the vehicle. So being a startup, we're not constrained by tradition. So we could and may actually eventually build something like this into the system when we launch it.
Okay, we're mask free and just outside of the Atlis factory. What did you think of that?
Right. That was really cool. I had no idea that they built something that they're going to build a truck that's not disposable like your typical trucks around here.
Yeah.
It's for heavy duty, and you buy it once and you'll keep it forever. If it needs anything maintained, they'll be able to do the maintenance here, or maybe in the future somewhere else in a different location. Yeah, I really like the concept that they're not just buying parts out of a bin from some other manufacturer, that they're designing their own stuff to their own specifications and with the customer's needs in mind, and it's all long-term thinking, and it's great for the environment.
Yeah, I can't wait to see what the future brings. I guess we're definitely excited after this tour, and anticipating seeing the first Atlis vehicle roll off the assembly line here, the final assembly line in Mesa, Arizona, in the near future.
Yeah.
Yep.
I hope that it's not here. It's over by Mesa. Jupiter Rings is in Phoenix.
So right now we're heading back to Old Town Scottsdale. Is that downtown Phoenix? Or is that something else? Scottsdale, downtown Phoenix? What is that? Scottsdale, yeah. Alright, that's Scottsdale. Yeah, that is gotta be Scottsdale, because it's way too close to be downtown Phoenix. We're gonna try the parking garage this time. 3-hour parking, free. This is the nicest looking parking garage I've ever seen. What do you think?
Get some clothes on.
All right, we're gonna get some vegan hot dogs for lunch. I know it's nice and healthy and nutritious, right?
Yes.
Super healthy.
Yes.
Let's go for it.